This presentation gives you an overview of the concepts and practices outlined in the chapter on section views in your textbook. After studying the material in this chapter, you will be able to understand the concepts of sections and cutting plane lines, apply correct section lining practices to your drawings, recognize and draw section lining styles for 10 different materials, draw a section view from 2 other views, demonstrate correct hidden line practices when applied to sections, identify 7 different section types, apply section techniques to create clear, easily read drawings, demonstrate correct sectioning for ribs, webs and spokes, use hatching at conventional breaks in elongated objects, and understand and interpret drawings that include section views. There are 3 main purposes for drawing section views. They are to document the design and manufacture of single parts that are fabricated as one piece, to document how multiple parts are to be assembled, and to assist the visualization of the internal workings of the design. To create a section view, one must think of the part being cut or sliced through by a knife or a cutting plane. When the part is cut full in half, the resulting view is called a full section. A cutting plane line is shown in a view adjacent to the section view. The cutting plane line indicates where the object has been cut and the direction in which the observer will view the section. The visible edges of the object behind the cutting plane are normally shown because they are visible, but they are not cross-hatched with any section lining. Only the area of the object that was cut by the cutting plane, the newly visible edges, get cross-hatched. Your textbook shows illustrations and examples of this. Use the step-by-step section of this chapter to demonstrate the visualization of a full section and to demonstrate the projection of visible lines for section views. Each section is completely independent of the other and drawn as if the other were not present. In this example, section AA is drawn as though section BB were not there, and section BB is drawn uninfluenced by the presence of section AA. Sections are labelled independently of each other, the label being placed underneath the section view to identify each section. Notice in this example how section AA replaces the front view and section BB replaces the right side view. The rules for representing lines in a section view are: show the edges and contours which are now visible behind the cutting plane, omit hidden lines in section views except in rare cases when they may be necessary for clarity. A section area is always completely enclosed by solid, unbroken lines. In a section view of an object, the section lines in all hatched areas for the object must be parallel, and visible lines can never cross sectioned areas in a view of a single part. There are 2 types of cutting plane lines. Your textbook favours a type of line that has equal dashes. VCC adopts the alternate cutting plane line that has long dashes and short dashes with equal spaces between the dashes. Line thickness is the same as for visible object lines. Both styles have arrows indicating view direction at either end. Use capital letters at the end of the cutting plane line to correlate with the labelling of the drawn section. Placement of the section view follows the rules of third angle projection. If your section arrows point to the left, indicating a view looking in that direction, the section view is placed to the right of the main view, as in detail A. Detail B should be corrected by placing the section view on the left side of the main view. Detail C indicates that turning the section arrows in the opposite direction will be another way to correct the error. Your cross-hatching lines should follow good drafting practice in that they should be uniformly spaced, not too close to each other, of uniform thickness, clearly thinner than the object lines, and terminating exactly on the section outlines. The usual angle for simple cross-hatching is 45 degrees, but this may be overruled when the angle conflicts with the geometry of the section surface. The drafter should ensure that the cross-hatching is not parallel to the outline of the section, nor at right angles to it. There are conventions for showing different materials in section, some of the most common of which are shown here. In level 1 of your program, you will be using hatch pattern number 1 as your default pattern. When you get into your specialty, the ones you are most likely to run into are steel, concrete, wood, and earth. CAD programs usually include libraries that allow you to select from a variety of section lining patterns, making it easy to use different patterns, angles, and scales for the spacing of the pattern. Be careful to follow any standards that may apply in inserting these section lining patterns. Symmetrical objects can be shown effectively using a special type of section view called a half section. A half section exposes the interior half of the object and the exterior of the other half. This is done by removing 1/4 of the object. Half sections are not widely used to create detailed drawings showing how to make a single part, because it can be difficult to show all the dimensions clearly when some internal features are only partly shown in the sectioned half. It often happens that only a partial section of a view is needed to expose the shape of the interior detail. Such a section, bounded by a break line, is called a broken out section. Your textbook has further examples of this. Many objects of irregular shape cannot be clearly represented by any of the traditional sections. In some cases it is proper to revolve the object to obtain a longitudinal view. This is called a revolved section and is used to show the shapes of a bar, a spoke, or an arm. To create a revolved section, first imagine a cutting plane perpendicular to the center line or the axis of the object. Next, revolve the plane 90 degrees about a center line at right angles to the axis. The visible lines adjacent to the revolved section may be broken. A removed section is one that is not in direct projection from the view containing the cutting plane. That is, it is not positioned in agreement with the standard arrangement of views. Removed sections should be labelled, such as section AA and section BB, corresponding to the letters at the end of the cutting plane line. They should be arranged in alphabetical order from left to right on the sheet. Section letters should be used in alphabetical order, but letters I, O, and Q should not be used because they are easily confused with the numeral 1 or the 0. In sectioning complex objects, it is often desirable to show features that do not lie in a straight line by offsetting or bending the cutting plane. These are called offset sections. The path of the cutting plane is shown by the cutting plane line, which bends or turns 90 degrees to place an emphasis on special features of the object. The offsets or bends in a cutting plane are all 90 degrees, and the bends in the cutting plane are never shown in the sectional view. To avoid giving a false impression of thickness and solidity, ribs, webs, gear teeth, and other similar flat features are not hatched with section lining, even though the cutting plane slices through the object. If a rib is sectioned when the cutting plane passes through it flatwise, it is often difficult to tell whether the rib is actually present. You will have several exercises on which you can practice these principles. When parts with angled elements are sectioned, the cutting plane may be bent to pass through those features. The plane and features are then imagined to be revolved into the original plane. The angle of revolution should always be less than 90 for an aligned section. Do not revolve features when the clarity of your drawing is not improved. Again, you will have examples that allow you to practice aligned sections. If space is limited on the paper, or to save time, partial views may be used with sectioning. The section view, combined with the partial main view, provides all the information required. Another method of drawing a partial view is to break out much of the circular view, retaining only those features that are needed for minimum representation. Whenever an intersection is small or unimportant in a section, it is standard practice to disregard the true projection of the figure of intersection. Larger intersections may be projected in the correct manner. Note that the larger hole K is the same diameter as the vertical hole. In such cases, the curves of intersection appear as straight lines. Conventional breaks are used to shorten the view of an object that is too long to show clearly at one scale on the drawing sheet. Cross-hatching is often used when showing a conventional break. Section views are often used to create assembly drawings. Notice that the hatching on different parts made of different materials have different hatch patterns. If the two parts were to be made of the same material, meaning the use of the same hatch pattern, the patterns would be drawn using different angles, usually at 90 degrees to one another. All hatching on a part is always at the same angle to help you recognize the parts easily. Solid features that do not have an interior structure are not hatched. 2D and 3D sectional views are created using CAD. Most CAD systems have a hatch command to generate the section lining and hatch patterns to fill an area automatically. In summary, sectioning is a necessary skill for any drafter to develop because it is used to document the design and manufacture of single parts that are fabricated as one piece, to document how multiple parts are to be assembled, and to assist the visualization of the internal workings of the design.